Hey everyone, welcome to part 3 of my ZZ tutorial. In this video, I'm going to show you guys how to orient all the misoriented edges you may find on a scrambled 3x3. So how this video is going to work is I'm going to run through with examples of all the possible edge orientation cases that could happen in terms of number. So what you could get is anything between 0 and 12. Of course, they must be even numbers because edges are oriented and misoriented in pairs. So you can get anything from 0, 2, 4, 6, 8, 10, or 12. Those are the only things that could happen. If you get anything else, somebody's flipped an edge or something. But in any case, you can only have those options. So I'm going to go through all of those with examples so you can see visually what happens. Before we start doing it, I'm going to show you guys some basic edge orientation strategy, and that will serve as kind of a guide for what we'll do in the future when we go through those cases. Alright, now let's talk about basic edge orientation strategy. What I'm going to show you first is the one move that changes edge orientation, because in order to turn something from good to bad, you need some sort of way to change it, whether it's a tool or a method. In this case, I like to think of it as a tool. It's actually one move, and that move is a quarter turn, and that quarter turn can be applied on either the F face or the B face. And in order to prove that to you, I'm going to first work with this cube here. This cube has a 4-flip performed on the front blue face. As you can see, all the pieces are flipped in their place. So it used to be solved, but I just flipped these 4 in their place, and now they're misoriented. You can also justify that they're misoriented simply by just checking with the rules. You can see, for example, that this is not facing up, so it's wrong. So there are many ways to distinguish why this is wrong. Let's just say they're all wrong because they actually are, and proceed with the F turn that I'm about to make on this cube. So I'm going to make an F, and after the F, all the edges in the cube will be oriented. So let's take a look. Alright, so I performed the F, and the piece that was originally here is now here. You can see it. It's yellow and blue. It used to be between the yellow and blue centers, and it is magically oriented. So to prove that, you can solve this piece by doing R and U, and that's well within the rules of an oriented edge. It can be solved in its place without the use of an F, F prime, B, or B prime, or any sort of front or back quarter turn. Likewise, this piece can be solved here by doing U, L. And the other two pieces follow a same pattern in terms of how they're solved to their original spots. So as you can see, the F really makes a big difference in terms of edge orientation. It changed all the edge orientation in the front. So now what I'm going to do is reset it to its original position. Now it's that 4-flip again. And I'm going to perform an F prime, just to check. And so this is what happens after I make an F prime. You can see the pieces shifted a little bit, and I can see that this piece that was originally here has moved to here, and you can solve it by doing L prime U prime, right? So you know that this piece is right, and all the other pieces follow a similar pattern in terms of how they get to their original places. So any sort of quarter turn on the front or the back works, because you can just turn the cube like this and the back will become the front. So any sort of front or back quarter turn will change the orientation of the edges on that face. Now let's talk about edges in general now. Edges have only 2 orientations because they only have 2 stickers. So it can either be like this, or it could be flipped the other way, as if it's correctly solved. Which means that if you perform an F on a wrong edge, it'll become right. And if you perform an F on a right edge, it will become wrong. So in a sense, like 2 wrongs make a right. Only here. Only here. So I'll show you guys with this example now. Here is a cube that has a 2-flip on the front. And what a 2-flip is I flip this one and this one here without affecting the rest of the cube. So what I'm going to do is an F turn, and I'm going to kind of test out what I just said. If what I said was true, these 2 that were originally wrong will become correct, and these 2 that are originally right will become wrong. So let's try it. F. Now you see the pieces moved from here to here. These two pieces are correct now because this one can be solved by RU, right? And this one can be solved LD, right? And this one is wrong because it would have to get here using some form of F prime, and this one would have to be here also by an F prime. So as I said earlier, if you apply an F on a correct edge, it'll become wrong, and if you apply an F on a wrong edge, it will become correct. So, and that's the nature of the edges. There's only two ways it could go. So if you make one wrong, it will be right, and if you make one right, it'll be wrong, kind of like that. So as you can see, the F turn can fix four edges at once. And what I'm going to show you is how to get four edges onto a face through the use of a brief example. This is just a black cube, but I stickered four edges to kind of to represent the wrong edges on a scrambled cube. So I'm going to scramble this cube like this. All right, let's just see this first. I'll scramble it to include less edges on the front. But say this is the front, and I want to correct all the edges. If there are four edges, all I need to do is place all of these edges onto the front face, this face that's facing us right now, and do some sort of F or F prime, and they will be oriented. So as you can see, this piece is the only piece that's not currently in the front. So what I'm going to do is I'm going to move like this, R, and then a U. And that will force all the misoriented edges to the front, and then I can do an F. Okay, I didn't actually do anything because these are all yellow stickers, but on an actual cube with misoriented edges, you will see them become right, and that will be illustrated in the examples I will show you later in the video. But for now, all you need to know is in order to fix four edges, you just place them all in one face by moving the wrong edges around, and then you correct them with a quarter turn. So let's set up something else here. All right, so sometimes you only have two over here. What you do is you move the other two onto the face. It's really the same logic. So I have one here and I have one back here, and two of them are in the front. So I'm going to first move this one here, and then I'm going to move this one here by first doing an F2 and then an R2, and they will all be on the same face. So the point is, all you need to do is get four edges on the same face, and then you will have an opportunity to correct them with an F or an F prime turn. And this also works for the B face. You just apply a B or a B prime after collecting four edges on the back face. That's a good question. So the question was, what happens when two edges are wrong only? The answer is not just simply do an F turn, because if you see, there are only two wrong edges, and if you do an F turn, the ones that were originally right will become wrong, and it will result in a never-ending cycle. And the only thing you're going to end up changing is where the wrong edges are without actually fixing them. So what I did here was I set up a cube. All the white edges are good, and all the yellow edges are bad, and there are only two of them. So the white edges are kind of all over the place. And this signals that there are only two wrong edges. So the first thing to do, if you have only two wrong edges, is make sure one is on the F or B face and the other one gets off of the F or B face. So what I'm going to do is move it down here. You can see now there's one wrong edge here and one wrong edge here, and this edge has been moved so that it's not on the F face, so it won't be affected by any of the quarter turns I do to change orientation. Keep in mind that these three edges are good. Okay? So now what I'm going to do is I'm going to apply an F turn, and it will make this bad edge good, but it will make these good edges bad that were originally good. So what I'm going to do here is take this Sharpie marker and mark these edges as bad. And I'll mark it with an X, like this. Okay? And this one is good, so I'll mark it with an O, kind of like that. Right, so now from this position, we have created 3 bad edges, denoted by the X, and 1 good edge, denoted by this O. What we have here, down here, is a bad edge that we purposely moved out of the way. So now what we're going to do is place this bad edge over here, X, and now all of them are bad in the face. And then what I'm going to do is some quarter turn to fix them. So what the idea is you turn 1 bad edge good, purposely making 3 good edges bad, and then you pair up the other bad edge with the other 3, and you group them all together, and then you get all the edges oriented. So it works kind of like that. It's not as straightforward as simply having 4 edges wrong, but that's sometimes something you just have to live with. So this is pretty much how to fix 2 edges. And everything else in terms of how to do it will either be based on fixing 4 at a time, fixing 2 at a time, or purposely making good edges bad to make life easier. Alright, so this is a scramble, which I manipulated at the end with the moves between the parentheses of a cube with no wrong edges. And please make sure to scramble WCA orientation, which means green front, white up. I use this orientation because I'm used to it for scrambling, so all I do afterwards is I do an X2 to really see what's going on here. This is the angle that I inspect, and I've noticed there are no wrong edges. So from here, what I'm going to do is simply go for the EO line because the EO has already been done for me. Keep in mind that the probability of this actually happening is slim to none. It's about 0.05%, and those aren't very good odds. But if you do end up running to something like this, very good, because you'll most likely end up with a good time because a lot of the stress involved in fixing the edge orientation is just automatically relieved by the scramble. Just to get a little bit ahead, what I'm going to do here is solve the EO line. So I have my blue line piece here and my green line piece here, and I'm going to move the blue one down and then the green one down and then a D prime to solve it, kind of like that. The moves I made were R prime, L2, D prime. So if you want to try that on your scrambled cube, I'm sure you'll get this also, and you can check out your EO line. Alright, so let's take a look at this scramble here. In this scramble, there are 2 wrong edges. The first one is over here, and the second one is back here, kind of like this. And the logic is very similar to the 2-edge example that I discussed previously, where you make one edge purposely right, and by doing so, you purposely make the other 3 edges that were originally right wrong. And then you group an edge that you don't affect with the 3 new ones that you purposely made wrong. That makes 4 because 3 plus 1 is 4, and then you correct all 4 at once. So you're actually going from 2 edges to 4 edges and then to 0 edges. So despite being fewer edges, 2 is actually takes a little more work than 4. It's kind of funny, but it's not too bad because when you only have 2 edges, everything is really easy to see. So let's get started. So what I'm going to do here is move this one over here using an F move, and this one will be correct, and these 3 will be wrong. And then the one in the back here, I'm going to collect on the front face just by doing an R2, and then I'm going to do another F face quarter turn to fix my edge orientation, and now all the edges on this cube are properly oriented. So despite being slightly more work, it's really not so bad because it's so simple, and nearly all of the 2 misoriented edge cases will be solved in this type of way, and if not this exact way, using a very similar thought process. Okay, let's take a look at this scramble. It has 4 wrong edges. I have 1 wrong here, 1 wrong down here. So far 2 are wrong here, and 1 wrong here, and 1 wrong here. So what I'm going to do is use the front face to group all the edges together. So this one's already here, so I'm going to let it sit here. First, what I could do is move this one down here, by using an R prime, and move this one over here by doing a D. Now I have 3 wrong in the front, and remember this one back here is wrong, so I'm going to do a U2. And now all 4 wrong edges are gathered in the front, and I'm going to do an F prime to solve all the orientation of the edges. And now all the edges are oriented, and if you follow along, you can verify that one on your own cube. Alright, so this is a scramble with 6 wrong edges. I have 3 in the front, this one wrong, and this one wrong. And this one on the side is wrong over here. And this one is also wrong. And lastly, this one is wrong in the back. It's actually in the back here. So what I can do with 6 is the following technique. I like to call it 4 plus 2. And the name suggests exactly what I'm about to do, which is fix 4 and then fix 2. And this isn't always the best way to do it, but I'm just going to show you anyway for the sake of example. This series of moves I'm about to make will just orient the edges. I'm going to ignore solving the EO line. This is just to orient the edges. I'm sure there is some better way, but just for the sake of showing you guys how to orient the edges, that's just what I'm going to do. So I have 3 wrong over here and 1 wrong over here. So I'm going to put this one over here. And now the 4 wrong are in a group. I'm going to orient them with an F turn. So now they're fine. And I'm going to look here on the back. I have this one wrong and this one wrong. So what I'm going to do is I can't have these two on the same face because an F would just cause that never-ending cycle I described earlier. So I'm going to do a U to get this off the front face. And now this is the only one on the front face over here. And these 3 edges are correct. So I'm going to do an F, making these 3 edges wrong and grouping this one into it. So now all of these are wrong, and I'm going to do another F to fix all the edges. And you might have noticed that the way I just oriented these edges, the way was very, very long in terms of move count. It had many, many moves, and that's not the best way to handle 6 if the case doesn't allow it. So here's another way you can think about 6. This is the exact same scramble, but instead of doing 4 plus 2, I'm going to do something called 3 into 1 into 3. So as that name suggests, I'm going to fix 3 edges, and anytime I fix 3 wrong edges, the one that I turn on, say, the front face that's originally right will become wrong, because you can think about it like a light switch, right? There is an on and an off. So anything that is currently right will be wrong once I do the quarter turn. So you can see these 3 are correct. So say, for example, if I did an F, this one will be wrong, and then I'll have this one to group with the other 4. However, I'm not going to do this because the move count would be atrocious also. So instead, I'm going to look here in the back. This one is wrong, and this one is wrong. So what I'm actually going to do here is move this one over here, right? And this one will accompany these 2, and it will create a group of 3 wrong. So what I'm going to do here is move this edge, do an L2, and now it's with this. All right, and then I'm going to do a B turn to orient all the edges except this one, because it was originally right here and good. Now it's become bad. And the state of my cube right now is I have this bad, this bad, this bad, and that bad. So next what I'm going to do is a U, and then an L, and then an R prime. And now I have collected everything in the front. Bad, 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 bad. F prime to fix it. And now everything is good. Alright, so here is a scramble with 8 wrong edges. There are 3 wrong ones in the front. So this one, and this one. And there are 4 wrong in the back. wrong, 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 wrong. And the last one is down here, and it's wrong. So how you deal with 8, 99% of the time, is you do 4 plus 4. What that means is you orient 4 and then you orient the other 4. In this case, the 4 we're about to do are really easy because they're already in the back. So I'm just going to do a B to orient them. And now I have 4 left. I have 3 in the front here and 1 down here. So I'm going to move. This is actually the D face, but I'm going to keep everything in view. I'm going to do a D and then an R. And now all the wrong edges are in the front, and then I can do an F to orient them. So 8 is relatively straightforward because most of the time it will be 4 plus 4. Okay, so this is a scramble with 10 wrong edges. Instead of telling you where the wrong edges are, I'm just going to tell you where the right ones are, and then you can just assume everything else is wrong. I checked the scramble multiple times, and I'm sure there are 10 wrong. So this one is right. Down here, the green and white one, and this orange and blue one is also right here in the back. From my angle, it's like this. Everything else is wrong. So if you want to follow along here, just do that scramble and just check for yourself and just check everything else just in case. Everything else should be wrong. So before I actually start moving, I'm just going to describe in words how to do 10. Generally, what happens is you solve 4, or you orient 4. I use solve and orient interchangeably. So you orient 4, and then it becomes 6. And what you do there is either 4 plus 2 or 3 into 1 into 3, which are both strategies that I pointed out before. The good thing about 10 is that you're bound to have uh, 4 or very close to 4 on a front or a back face because of just how many there are. So what I'm going to do here is I'm going to solve 4 and then move into a 3 into 1 into 3. So here goes. I see that there are 3 wrong in the back here. I'll give you a full view of the edges. And this one is 1 move away from being solved. So I'm going to move this one here, and now there are 4 wrong in the back. I'm going to do a B turn, and now they are all oriented. Let's check what we have left. So we have 3 wrong in the front, and we have this one wrong, and this one wrong. So they're all on the rim here. So I'm going to do an F to orient the 3 that were wrong over here, and purposely make this one wrong, and then move this one here, move this one down here, and move this one over here. And now I have 4 that are wrong in a group, and I would do an F turn. Another way to do 10 that's very similar but has a different start is making 3 wrong into 1. And it's kind of like, if you take 3 steps forward and 1 back, you're taking 2 steps forward. So in our case, it would turn into 8, and then you can do 4 and 4. So that could also work out. But 10 is rather tricky, but because there are so many edges everywhere, it's very easy to find 3 in a face or 4 in a face, and you can proceed with whichever strategy feels best. So here is the dreaded all 12 edges wrong case. This is the maximum number of edges you can have wrong on a 3x3. And if you are a ZZ solver, you will have to correct all of them before making an EO line. And to some, that's a really difficult task. Before I get started on fixing these edges, I'm just going to have to point out that the series of moves that I had down here a while ago wasn't actually a legitimate scramble. It's far too short, and it's just a bunch of moves I made to misorient the edges, just to show you how I would orient them. Um, so um, there are 2 main ways to take care of this 12 edges wrong case. The first one is pretty much intuitive, and the second one is algorithmic. So I'm going to get to the intuitive one first. I read around a lot, and a lot of people seem to say, okay, just do some form of F move and some form of B move, and then what you have left is you fix the 4 in the front, you fix the 4 in the back, and then you have 2 wrong over here, and 2 wrong down here, and it's like wrong around this rim. And on paper they say, okay, well, you can reduce it to a 4 edges case, so it's not so bad. But let's just try it anyway. So F and B prime, just because you can do it in one motion. And now I have 2 wrong here and 2 wrong here. And from this position, it's actually really hard to get everything to the front face. It takes a lot of moves, and it's not exactly finger trick friendly. One possible way would be kind of like this. Um, and I orient all the edges. It's not very efficient, so I normally don't like this approach. However, what I do like is the algorithmic approach, and I'm going to show you how it works. So there are 12 edges wrong. This is the same quote-unquote scramble. What I'm going to do is apply a 7-move algorithm to solve the edge orientation. It goes like this. F, U, R, D, B, L prime, F. And notice the F prime right after the F is in parentheses. That means that I can actually choose what quarter turn to make for the last move, because both options F or F prime result in orienting the edges. So you have a little freedom there, and you can also mirror or do a lot of cool tricks and change the way you affect your edges while you execute the algorithm. And if you're really paranoid about 12 edge wrong cases, you can just play around with the algorithm and see how exactly it affects the edges, and it'll give you a pretty good shot at tracking your edge pieces for the line while you do the edge orientation, which is obviously what you do while you plan an EO line. It's not only fixing the edge orientation, it's tracking your line pieces. So the algorithm uh, could give you a better shot at really figuring out the thing as a whole, versus the just do an F and a B immediately and then scramble to get the other 4. I think the algorithm is a little bit cleaner for that. All right, so here are some closing thoughts. So the edge orientation solutions I had in most of the examples don't really represent the best way to do things. Generally speaking, people solve the line after the EO and plan their EO such that the moves that it takes to orient the edges influence the 2 line edges. So these 2 line edges down here influence it in a positive way, so the line becomes easier to place. What I did this video was just simply orient the edges and just leave it at that. In the next video, I'm going to show you guys some examples of how to integrate the line with orienting the edges, and I'm going to work over all of these scrambles again, and we'll figure out the best way to solve the EO line, or at least my best way to do it. So I hope you enjoyed this video. If you have any questions, feel free to post, and we'll work things out. EO is by far the most complicated and unique aspect of ZZ, that is orienting all the edges in the beginning versus Rue's 6 edges and Petrus's 7. So it definitely sets the method apart and should be practiced a lot. I find after I practiced a lot, my EO solutions were much more creative and much more flexible, and of course they were faster to plan. So just keep in mind that it's really a method that you have to put time into before you can have that like aha moment. So just remember to put time into it and work hard and don't give up even if there are too many wrong edges.